Good morning, everyone. I hope I am audible.
Yeah, you are.
Okay. Thanks, Professor Atre. So I am very delighted to introduce my colleague, Professor Nagendra Velaga, who is one of the recipients of IRCC Research Publication Award of 2020 this year. So Professor Velaga joined our department in the year 2013 after his postdoctoral fellowship at UK. Currently, he is associate professor in our transportation system engineering group of the department, and his main area of research includes intelligent transport system, human factors in transport system, accident analysis, and driver safety, transport accessibility, and mobility. He already has published more than 50 research articles and peer-reviewed journals in the last 5 years. Also, he has completed 6 collaborative sponsored research projects and is currently working on 5 sponsored research projects funded by various reputed national and international agencies. We are very proud of Professor Velaga for his excellent research contributions for the department and institute, and heartiest congratulations to Professor Velaga. And also, we congratulate all the institute research award winners of IRCC this year. So with this brief introduction, now I would like to welcome Professor Velaga for his talk on human factors in intelligent transportation systems, distraction due to mobile phone during driving. So over to you, Professor Velaga.
Thank you very much, and I hope I am clearly audible. Thank you for introducing me, Professor Deepankar. So here in this particular presentation, I'm going to cover some aspects of introduction to human factors, and also whatever the case study that I have been saying, that is the distracted driving. And finally, I will end up this presentation with some ongoing research in our laboratory. So coming to the introduction to the human factors, if you take any transportation system, we will have 3 components, that is the human, infrastructure, and vehicle. So if you exclude the basic COVID and the pandemic, normally we can see about 150,000 fatal accidents and deaths due to road accidents in India. That is as per the standard reports, and majority of them are due to human factors. At least 80% of them are due to human factors. And within the human factors, if you talk about what are these human factors and how are they related to transport system, so we can consider the physical and physiological parameters, mental parameters, and the psychological parameter. These are the 3 basic components or the human factor components which we can consider in the transportation systems. So before I go further into that ITS and so on, let me introduce you that human factors and what are they. So example, human factors includes the decision making, distracted driving, and when we are driving during the time pressure or the aggression, perception or reaction, and driving drunken drive and fatigue and sleep deprivation. So these are some of the human factors that will be influencing the driver and passenger safety, particularly during the driving component. And when we talk about the human factors and how is it actually connected, let me explain you with a small example here. So if you look at just a passenger car, and here driver can see some obstacle, either a pedestrian or some obstacle here. As soon as the driver observes that particular obstacle, the driver is supposed to stop the vehicle. So the driver first need to react to that particular complete instant, and that we call it as the during that particular time, during that particular reaction time, and the driver will be actually driving, that we call it as the lag distance. And after that, driver decides that, okay, let me stop, let me press the brake. And then after that, after start pressing the brake, the distance covered by the vehicle, we call it as the braking distance. That's what the total stopping side distance. I hope all of you can see my cursor. Am I right? Could someone confirm that whether you can see my cursor?
Yes, sir.
Yeah, thank you. So here in this particular case, if you talk about the distracted driving, is that reaction time going to be same? So for instance, our IRC codebook recommends that the reaction time of driver is considered as 2.5 seconds. So is that going to be same or not? So these are some of the questions we can see. I cannot move the slides. I cannot move the slides. So I think something happened. I could not move the slides further.
We'll just check, Professor Velaga.
It's moving now.
No, I can see the same slide. Let me again reshare that whole thing.
Yeah.
That would be better.
Yeah, we can see now.
Yeah, now it is perfect. Thank you. So here in this particular case, I was explaining that when we are actually distracted, that effect also might be there on the vehicle control also. That vehicle control could be with reference to lane position or with reference to lane excursions and the mean lateral acceleration and also certain other parameters such as the steering reversal rate and so on. So here we were observing all these components just to give some idea about what are these lateral driving performance measures or the vehicle based measures. I'm going to show you a small video here. So with that video, you can actually observe that what do I mean of the human factors in the complete driving scenario. Say, for example, in this particular case, you can see that the front vehicle, you can clearly observe the front vehicle. That vehicle is actually going off the road and again going in the opposite lane and so on. So if something to do with the vehicle or the issue with the vehicle, driver would have safely stopped aside. And it seems that it's very likely, high probability that driver is fatigued. It's a sleep deprived driving. So that is the reason driver is going off the lanes and again coming back and so on. So you can continue see that particular driver. Finally, it ends up with some accident here. It might not be something to do with the vehicle. If something to do with the vehicle, driver would have stopped aside. And this is what I can say that the effect of such human factors will be there on driving performance. Now, finally, it ended up with a kind of major accident here.
Is that the actual case? Velaga seems to be having problem with the connection.
Yeah, it appears to be, one cannot simulate such an accident, so it must be an actual accident.
Right. How could you record it at that time? But
Yeah, no, that's a different point, but yeah. It's possible that many cars will have cameras in front,
yeah.
not for just for safety of that driver and insurance purpose, etc. Many times people keep cameras. Yeah,
Professor
I'm sorry,
Velaga?
it was,
this is
yeah,
in the
I'm sorry,
previous
it was somehow disconnected. Can I
Yeah.
continue?
Yeah, please continue. Just a question arose while you were away. That is that actual recording of the actual happening, or it was kind of a simulated exercise?
No, it was recording of actual happening. It was recorded through dashboard camera.
I see. Okay. Great. Please go ahead.
And the next component, that is the human factors in ITS distraction due to mobile phone. So we have actually conducted some experimentation and the results from these research papers, I'm going to show the glimpse of such results. So here we were actually, before I go into that, what is this distracted driving? That distraction could be due to mobile phone, eating, drinking, and conversing with passengers and so on so. But some of these distractions are legally not allowed. Some of these distractions, such as eating, drinking, that's legally allowed. But those are distractions. When we talk about distractions, we always feel that it is happening in India. But the reality is that throughout the world, that problem is there, particularly phone use during driving. That problem is there throughout the world, whether we call it as UK or Australia or the USA. So that is the worldwide problem. And at the same time, in this particular case, we were actually trying to study the reaction time of the drivers and the effect on speed and the lateral performance measures. So in this case, we were actually trying to do this complete component using a driving simulator, because we did not get the ethical approval for the field studies, because legally we are not allowed to use the mobile phone during driving, which I completely agree with the ethics committee. So here we were actually conducting the experiments for both conversation and texting. We have divided that conversation and texting with simple and complex level. If I talk about the simple conversation, that includes that the one which is already in your mind. For example, what is your name, what is your hometown, and so and so. The complex conversation is something like little bit small arithmetics, giving some additions, subtractions, multiplications, and so on, in which case driver need to think and answer. Similarly, the simple and complex texting level, that's actually segregated based on the length of the text in the existing literature. So based on that, we have conducted that experiments. And in fact, that experiments were conducted using this driving simulator in our laboratory. We have actually done a 4-lane undivided rural highway with 3.5 kilometers stretch and so on. And then further, we have actually introduced two sudden events, a group of pedestrians crossing the road, and also some road joining of parked vehicle. So these are the two scenarios we have created. And we have actually measured the difference to reaction time, speed, and accident probability, some lateral performance measures. So when we looked into the reaction time of driver, and we can clearly see that the mean reaction time for no phone use condition, that is 0.99, whereas for the complex texting case, it is going up to 2.72. That is the mean reaction time, which is actually more than what we consider in our design, transportation system or the infrastructure design. If you look into the 90th percentile and certain percentiles of that reaction time, that's indicated in the bottom picture here. But whatever is the additional load, that's actually creating some impact on driver reaction time. That is the one of the findings that we can say. And when we talk about the reaction time, here we have actually done some survival analysis. The y-axis, you can clearly see the probability of detecting the event. With increasing workload of simple conversation, complex conversation, we can change. We can see that the probability of not detecting is actually increasing. And normally what happens is, if you talk about any additional load, the driver's first reaction is let us reduce the speed. That is the compensatory measure driver will take. Say, for example, I am driving and I got a call. I will reduce my speed from 80 to 70, and I think that I can take my call so that I can drive safely. So this behavior is also observed here. But what we did was, with that reduction in speed, we were actually trying to consider whether that reduction in speed is appropriate or not. Say, for example, here in this particular left side picture, the y-axis is the accident probability and the x-axis is the speed. For the given speed of 20 meters per second, so the red color one indicates that no phone use. With no phone use, the probability of accident is maybe about 0.01 or so. And here are 0.05 or so. And here for the same component, if I increase the workload, the accident probability is increasing. And similarly, this is for the texting component, which is shown on the right side. So we have also done some sort of mobile phone use for the lateral performance measures, such as the standard deviation of lane position and so on. Here we have done some simple ANOVA test, and we found that the steering reversal rate, the 10-degree steering reversal rate, that can identify the all components of the simple conversation, complex conversation, simple texting, and complex texting. And to conclude that particular research part, here we have identified that the mobile phone use, which is actually impacting the reaction time, that is increasing the reaction time from 40% to 200%. And similarly, this particular accident probabilities are also increased 3 times to 4 times. And 1 meter per second increase in mean speed is actually creating 14% increase in the accident probability. So here the major limitation here is the work was conducted in the simulation, and we cannot, I mean, no researcher can do that in the field unless they have some test track and the controlled environment. So here, to conclude my complete component, most of the cases, what we do is, in case of the human factors, we create some ITS application, or we create some high-end artificial intelligence based applications in order to control the human, which can be actually done by the human. The basic principles of use seat belt, use helmet, and do not use phone while driving, don't do drunk drive, and so and so. So these are the basic principles. For that, we don't need any sort of high-end technology or artificial intelligence. So what happens is, for instance, we create a technology. For instance, the seat belt warning system, that's a technology was created. Then the drivers try to identify, or the human try to identify how to counteract the technology created by the human, which is not appropriate. For instance, the seat belt was kept backside of the driver in order to avoid this warning. So what I would like to request is, if we follow all the basic principles, we can actually, we don't need any high-end algorithms or anything. In olden days, if the person is actually tired, that person used to take rest at roadside. But these days, because of time pressure and workloads and certain certain lifestyles, it is actually the human attitude is actually changing. Just I would like to conclude my presentation with the ongoing research. Currently in our lab, we have altogether different high-end simulators of two-wheeler simulator, truck simulator, and car simulator. And we are fortunate, IIT Bombay, being in IIT Bombay, we are fortunate that only this IIT Bombay got all three high-end simulator. If you look at compared to all any other IITs. So currently I have been working on the fatigue and sleep deprivation and the influence of alcohol on driving performance. This work we have already done using the car simulator, and we are waiting for the ethical approval for the two-wheeler and the truck simulator. And we have been working on the time pressure, distracted driving, and perceptions and reactions, and so on. Before I conclude this, I would like to acknowledge that whatever is the facilities that were created, it was actually support from all my group members, and it was a kind of group task. So I would like to thank Professor Vedagiri, Professor Avijit, Professor Tommy Matthew, and Professor K.V. Krishna Rao, and some of my other colleagues for that. And of course, the last but not least, the research students. And without research students, the work cannot be done. I would like to thank all my research students for contributing in human factors in ITS. With this, I would like to thank everyone, and thank you for giving me the opportunity. Thank you, sir. I am done.